This question is about forces on submerged surfaces. Submerged surfaces. Right. The question is a sluice gate, just a gate. Right. We've done dams before, so we'll just call it a dam. It's a gate in water, right? So it's a sluice gate like this. It looks a bit like it. I'll just draw it like this, right? So here's my sluice gate. Right? And it's telling me it's holding back water. So we've got water on both sides, right? So we've got water on here, look. So here's my gate. Looking in this is the sluice gate, just a bit of metal holding water back, right? That's all it is. So sluice gate, so it's got, and then let's say that's the bottom there, look. So that's the bottom right now. The depth of water behind the gate is predicted to be 30 meters. So I'm saying we've got a bit of water, and the depth of this water, the depth of the water here, like I'm calling this behind the gate. The depth of the water here is 30, right? And the depth in front is 17. So we've got water here as well, look. And the depth of this water is 17 meters. 30 meters, okay, meters. Right. So we've got water here, look, or whatever it is, water. And the breadth of the gate is a massive long gate. So it's saying, just like we do with dams, like the breadth of this big gate, a big gate in it. So we've got a bit of 3D sketching going on here. That way. So the breadth of this gate, let me get a different color. I'm saying that the length of this gate, or the breadth of it, is 70 meters. So it's a bit like a dam, really, right? A bit like a dam. And we've got water each side of this dam. Water here and water here. And we've got to work out the forces and the moments on this dam. Okay, so it's forces on submerged surfaces. I might just rub this here off, I'll just get a bit of space going here. So forces on submerged surfaces. We know as well the density of both sides, the density of the water. So the density, symbol for density, a better pen than that. Symbol for density, so we've got 1020 kilograms per cubic meter. Density, huh? The density of the water, both sides. Right, we're not mixing stuff here. So that's what we've got. We've got 30 one side and 17 on one side. This gate is 70 meters breadth and it's holding back water of density 1020. We've got to find the resultant thrust and the turning moment. Part A, part B, perhaps. Because all of this water is going to cause a pressure and a force. So we need to find what that force is. That's the question. Now, if you remember, here's the formula. So the force due to water at depth, F for force, that symbol's density times by gravity. Okay, and what we've done is we've gone height divided by 2. That just means we're putting this force halfway. Okay, I'll get back to that in a bit, right? So force is density, gravity, height, right? That's the pressure bit, and we've got to times it by area to get it into force. That's what we're dealing with. That's the formula for the force, and then we've got to do moment. So the resultant first, so we've got to do the resultant, working both out, take one away. And then part B is the turning moment, the resultant turning moment probably. I put resultant in there because I'll probably do it that way. Resultant. There's a couple of ways you can do this question, see. So resultant moment, and we know that moment is force times distance. Bingity, bingity, bing. Huh? That's the problem. All right. So I'll draw it again, just to make it a bit. Right. Rather than doing 3D, I'll do it 2D. Here's our big wall. Here's our big wall or our dam or whatever it is. All right. And we've got some water this side. I'll draw that. So we've got 30 meters this side. Thinkity, thinky, think. And what we've got 17 this side. 17 this side. And what I'm going to do is, I'm going to say, just for simplicity's sake, that we're going to put the force halfway. So the force due to this water, I'm going to put it there, look, halfway. That's why we're doing height divided by 2. So it's going to be 30 divided by 2. Because, you know, at the top of the water, where there's no pressure, that's where there's least force. And down the bottom here, where there's loads of pressure, there's more force. So I'm going to go halfway to make it easy for us. Oopsie daisy, oopsie daisy. Right. And then delete down here. So that's what I'm going to do, because I can. And I'm going to put this force this side over here, look. That's also going to be height divided by 2. As in the 17 divided by 2 and the 30 divided by 2. So I'm going to label this one here F1. It's probably going to be the biggest one because I've got more water, and I label this one F2. And we've got to find the resultant. So all I'm going to be doing, I'm going to find F1, find F2. F1 is the biggest in this case. So I'm going to go F1, take away F2. Because the resultant force is going to try and push this dam wall or this gate that way. That's what I'm going to do. Okay. So we'll start off finding F1. Here's my force. Here. So density, gravity, height divided by 2 and area. So part A. Part A. I'm going to find F1 first. And I know the force is density, gravity, height divided by 2 times by the area. And I know that the density of this water is 1020. Density 1020, I think, isn't it? Yeah. Times by gravity, which we all know is 9.81. Thank you very much. Times by height divided by 2. I'm going to put it halfway because I can. So height this side is 30, so I'm going to do height divided by 2, or the depth of water divided by 2. That means I'm going to be doing 30 divided by 2. Because I'm putting the force halfway, make it easy for us. Okay, the pressure, most of the pressure really is 2/3 down. If you ever watched the Dam Busters, that's where the maximum amount of pressure is, 2/3 down. But for our sakes, we'll just put the force halfway. So that's density, gravity times by height divided by 2 times by the area. And I'll put a little bracket. The area is going to be 70 times by 30 because it's that depth of water there. Look, it's where the water's touching the wall. Right? So it's 30 times by 70. Number 70, so we'll do 30 times by 70. That's going to give you a number. Density, gravity, height divided by 2 times by the area. That's going to give me a big number like this. 315195300 newtons. Press the E and G button on your calculator and you will get something 1, 2, 3, 4, 5, 6, 315 point. Let's make it a 2, should we? Just because we can. 2 times 10 to the 6 newtons, which also equals 315.2 meganewtons. That's F1. So this F1 here, that's how much force is trying to push it over. We'll now do the same with F2. With F2 is going to be smaller in it because it's got less water. So we'll do B, F2, same formula, density, gravity, height divided by 2 area. Okay, different color pen and bought our pen. Let's go for blue. We're using water. So the density is still 10, 20, still 20, yeah, so 10, 20. Gravity is 9.81. The height now is different. The depth of water is different because we've got 17 behind it. So it's height divided by 2 because we're putting it halfway. So I'll do 17 divided by 2. Times by the area, which is a bit less. It's going to be, yeah, there you are, 70, look, times by that 17. How much water is touching the wall? The more water you got. Okay, so it's 17 times by 70. Obviously, you can do all of this in one go in your calculator. You haven't got to do like I've done step by step. You can just put that F1 in and then take away this here, look. But for me, F2 gives me something like 101212713 newtons. Press the E and G button if you like, and you get 101.2 meganewtons times 10 to the 6, isn't it? Because mega is 10 to the 6. So it's quite a lot of force. That's coming F2. F2 being there, look. So what we've got is this. I'll just do it quickly again. So we've got this bit of this dam or this gauge or whatever it is, and we've got this side. We've got F1 coming this way. Got F1 coming this way. We've got F2 a bit lower down coming this way. I've labeled them F1 and F2. It's up to you. But F1 is what have I done? I'll do the rounded up version. That's why you should use the calculator to do all that really. So 315.2. So we've got 315.2 times 10 to the 6 meganewtons, isn't it? Coming that way. And then we've got F2 coming the other way, which is 101. Right, 101.2 coming the other way. 101.2 10 to the 6 coming the other way. So F1's going that way, F2's going that way. So the resultant is going to be, I'll do the biggest one, right? So 315.2 times 10 to the 6. You don't really need 10 to the 6, but take away 101.2 times 10 to the 6. Your one might have F2 might be bigger. Okay, strictly speaking, you know, anything going to the right, okay, I put positive. Anything going the other way is minus, hence, okay. It's a big force, take away a small force. Which one's going to win? F1's going to win. What's the difference going to be? Whatever that is, it's 214 times 10 to the 6 newtons, which is 214 meganewtons, and it's trying to push it that way, innit? It's going that way because F1's bigger. F1's bigger, more water behind it, which means all of that 30 meters of water is going to beat that 17 meters of water. So F1's going to want to try and push this wall over by that much. 214 that direction. Okay. That there is part A. That's the resultant force. Okay. You can do it quicker than that. I've just gone a bit slow so you can see what's going on. That's the resultant force, part A. There, look, the resultant thrust and its direction. Resultant force, resultant thrust, okay? And direction. So the resultant thrust is 214 meganewtons, and the direction is going to your right, right? From left to right. That's your direction. Okay, that's part A. And then part B will be the turning moment. Okay, we've done most of the work, so the turning moment, or the resultant turning moment I'll do. So that's part A. Finished. Part B is coming up. Part B, we've got to find the turning moment, the resultant turning moment. Part A was the force and the direction, which we found out to be 315.2 going that way and 101.2 going that way. There, look. So F1's bigger. Put the forces halfway to make it easier for ourselves. And we found that it's 214. So now we've got to find now the resultant, the result of resultant moment about the base, all about the base, remember that song? So all that means is F1 has got a force, it's also got a distance, so it's going to try and push this wall clockwise, and F2 is going to try and turn it anti-clockwise, right? Moments we've done before. So we've got F1 trying to push it round, like the base is the base of the dam or the gate, that's the pivot point. So we're going to try and turn it around that pivot point, if you remember doing moments. So we need to find moments. We know that a moment is force times distance. Okay. So I'm going to find now the moment due to F1. Okay. So I know that moment is force times distance. So what's my F1? Well, my F1 was, what was my F1? 315.2. There, look, 315.2. So it's going to be 315.2. Don't forget the big number at the back. That's the force, because we're doing force times distance, right? So this is the force. Moment is force times a distance. So we've got times it now by a distance. And the question's asking us to do it about the base. The turning moment about the base of the gate. So there's the base of the gate there. And we've put our force halfway. So this force here is 15 meters, isn't it, from there to there? is 15 meters from the base. Because you put it halfway, make it easy for ourselves. So I'm going to do this now. I'm going to do times by 15. Because we put it halfway. Keep it easy. So that F1, look, is 15 meters up from the base. That's what I've done. So that'll give me the moment due to F1. Put that in your calculator, press the E and G button, right, because I don't want to write all these notes out, and you should get something like this, 4.728 times 10 to the 9, 10 to the 9. Right. You should get 4,728 and loads of notes. Press the E and G button on your calculator. Quite a lot, quite big force and big distance. That's how much moment is trying to push over. It's force times distance, so it's Newton meters. And which way is it trying to go? Well, here's my F1 there, look. And it's trying to spin it that way. Look, if you look at it, it's trying to go that way, which in my book is clockwise. So I'm going to put clockwise on here. It's trying to rotate that clockwise. CW stands for clockwise. So that's my moment due to F1, which is my biggest one, because F1 is the biggest force. And then do the same thing for moment due to F2, which is going to be force times distance. So moment is going to be, what is F2? F2 is 101.2 mega, and we've put it halfway, so it's going to be half of 17 divided by 2. So it's going to be 101.2. Don't forget the big number. That's right. So much force, and it was 17, wasn't it? 17. Yeah, 17 divided. But it's going halfway. So it's half of 17. So we put in 17 divided by 2. This is the moment due to F2. It's going to be smaller than F1 in it because F1 was a bigger force. So put that in, press the E and G button, and you should get something 8. No, you don't. 860, something like that. 860.2 times 10 to the 6 Newton meters. Force times distance. I pressed the engineering button there, so you should get 8602 and loads of noughts. And it's going, this force here, so it's going to be going anti-clockwise, isn't it? Because this one, the F1 one's going that way, because that's the pivot point there. That's going clockwise. This one's got to go the other way to counteract it. That's got to go anti-clockwise. I'm going to call that ACW. That stands for anti-clockwise. Okay, so one's trying to spin it one way, one's trying to spin it the other way. I call clockwise moments positive and anti-clockwise negative. So to find the resultant moment about the base, resultant moment about the base, all I'm going to do is take the big one from the small one. Luckily, this is the big one, so I'm going to do 4.728. Because that's going clockwise. 4.728 is times 10 to the 9, so it's quite big. There we are. And the other one's going the other way. This one's going anti-clockwise. That's minus, it's going the other way. Then take it away to find the resultant moment about the base due to this force of water. Don't forget that. Okay, take them away, press the ENG button, and you should get 3.87 times 10 to the 9 Newton meters clockwise. Not pennywise, that's a clown. Okay, clockwise because the moment due to F1 is the biggest one. So it's trying to, this water is trying to make this wall, this gate spin, if it could, on its hinge. It's good about the base, okay? If there wasn't enough support there. So if you want to put in 3.87 giganewton meters clockwise. Okay, that's the resultant moment. Everyone's a winner. That's the answer. Okay, quite big. It's massive, isn't it? Water pressure, quite a lot. So that's it. So we've done resultant thrust, resultant force and its direction, and the turning moment, the resultant turning moment about the base. Part A, part B, all done. You can do it quicker. You can just put the calculations into your calculator and rather do it step by step. Okay, everyone's a winner. Let's get a different pen. Everyone's a winner. Thank you very much. Ciao for now.